The chance to shape your future is here. Learn and connect with exciting new opportunities. Are you ready for the next step?
Good afternoon. Hi, everybody's arriving. Good afternoon. My name is Dr. Rachel Cross, and I'm going to be the chair for this afternoon's panel session, where we're going to be discussing how photonics is driving innovation in Wales. So I'd just like to introduce myself. I'm a lecturer in physics at Aberystwyth University here in West Wales, and I'm actually the co-academic lead from Aberystwyth on a partnership on the CPE project, the Centre for Photonics Expertise. As you may have heard about this project already earlier in the week, we had a session on Tuesday where we had some of our colleagues sharing some of their innovative work. And if you did miss that, please do catch up on that via the hub, or drop into our booth where you can talk to one of our business development managers. So we've got Carol and Hazel there ready to have a chat to you if anything is of interest later on for you. The Centre for Photonics Expertise is kind of what we've brought the panellists and myself together for this session here. It's a collaboration of 4 Welsh universities, that Aberystwyth is one. We've got Wrexham, Glyndwr, University of South Wales and Bangor University as well. So we'd just like to kind of start the session today by, a little bit about who I am. I use photonics in my academic research. I work with light and doing photoluminescence and optical sensors and optical instrumentation. But everybody here today has also got an experience of how they use photonics as well. So I'd just like to introduce the panel members, and I'll just ask them to come through in turn. So if I can pop myself down, so can we go to Eurion, please? Can you just tell us kind of a little bit about who you are and what you use photonics for in your industry?
Yeah, thanks, Rachel, and thank you for the opportunity to be on this panel. I'm Eurion Thomas. I'm European Operations Manager for Techion. Techion is a New Zealand-based company, but I look after the operations here, based just outside Aberystwyth. So literally, I'm sat 4 miles inland, if you went from where Rachel is, in Aberystwyth there. We're in the world of parasite diagnostics and parasite monitoring, primarily in food production animals, so primarily livestock. And the core of our technology kind of is this device here over my shoulder, which is all about digital imagery and sharing those digital images online. So yeah, photonics and imaging, optical kind of digital imaging is a core part of how we function and work in our main technology.
Super, thank you very much, Eurion. Then Nigel, if you could say a little bit about yourself and your company.
I can do, thank you, Rachel. Pananda, good afternoon. My name is Nigel Roberts. I'm quite recently the Chief Operating Officer now for iVapps on the global scale. iVapps is a valve solution that's designed to digitize the pipeline, whether it's offshore oil and gas, or currently we're launching the business into the water industry. I've done a short collaboration project with CPE, looking at how we can detect nanoplastics and microbe plastics in water. So the solution itself was invented in Wales with the support of Do It Cymru, Welsh Water. We're very pleased to bring that business back from Singapore into the global headquarters, which will be in North Wales.
Excellent, thank you very much, Nigel. If then as well, Kelvin, if you could say something, Kelvin James.
Hi, and thank you, Rachel. I'm Kelvin James. I'm the Managing Director of the Diamond Centre of Wales. We're based in Talbot Green down in South Wales, not very far from Cardiff. We are innovators and manufacturers of fine Welsh diamond jewellery. We do it all in-house. There's 2 floors of manufacturing and innovation and of design suites. Yeah, we supply the industry, but we're also innovators of machinery and tools for our industry as well. And this is where Aberystwyth and Bangor University from CP have come in line and doing a magnificent job for us so far.
Oh, thank you very much. Very kind of you. If maybe Caroline Gray, if you could introduce yourself and say where you're from and your role.
Hi, yes, good afternoon, everybody. I'm Caroline Gray. I'm the director of the OpTIC Technology Centre, which is owned by Glyndwr University. I'm also the lead of the CPE programme, and OpTIC is the base of the CPE programme, which spreads across Wales, between South Wales, Aberystwyth, Bangor, and ourselves in Wrexham. So very pleased to be part of that collaboration. The OpTIC Centre has a strong root in photonics technologies, including photovoltaic development groups with Swansea University at the moment, and also large optics, optical testing, metrology, and more recently, a large investment in the only research facility for thin film coating, vacuum coatings in Wales. So exciting things at OpTIC.
That's brilliant. Thank you very much, Caroline. And then last but by no means least, Matthew Wadsley, if you'd like to just introduce yourself, please.
Yeah, no problem, Rachel. Yeah, hi, I'm Matt. I'm from KTN. I'm the photonics lead for KTN. So KTN is all about connecting for positive change, and that's really what I do for KTN in the field of photonics. So my job's all about making connections between business to business, business to the research base, to RTOs like catapults, and to our government stakeholders. There's also a part of my job that's around promoting photonics generally, not least the word and getting politicians to use the word, but also working, to sort of raise awareness of photonics as a technology that underpins so much of what we do. And as part of that, I work with photonics groups and communities in all the nations and regions of the UK, and we do some European work as well. So that's me.
That's great. Thank you very much. And thank you everybody for joining us on this panel session. And just a little bit of housekeeping for those of you that are joining us for this session as well. Unfortunately, as if we were in a real live panel session, we'd be able to see all your lovely faces and interact with you. But at the moment, we can just see each other on the panel. But if you would like to interact with this session today, there's going to be a question and answer session towards the end, so in the last 20 minutes or so. But I'd like to invite you using the chat function in the platform, just to pop any questions that you have or thoughts as you're going along. And then there maybe can be something that we can use as jumping off points throughout the panel discussion. But then also if you've got any specific questions to ask, and if you, like I said, you have any questions that you wouldn't like to ask in text on there but maybe discuss them later, have a chat about photonics can interact with your company, have a chat to our business development managers Carol and Hazel that will be in our hub. Okay, super. Well, normally I'd be sat here with my cup of tea and my biscuits, which I feel a bit, from a panel session, I feel a bit cheated that I don't have my biscuits and tea provided to me. So this session is all about photonics and how it's going to hopefully drive innovation in Wales. So looking back, we're just over 5 years since it was 2015 when it was the International Year of Light, and photonics was very buzzword. I remember my little lapel pin that I had, it's still knocking about somewhere. And it's kind of thinking, are we still moving in the right direction with photonics? And firstly, when we say photonics, do people know what photonics is? It's often one of those words that people get confused, just as when you say, I'm a physicist, and people go, oh, I hated that at school. So think about photonics and how maybe it can help you. Hopefully we'll put a bit more of a human aspect to that in the panel discussion today. So from my point of view, as a physicist, photonics is basically everything to do with light. So it's the science and the technology behind light. So it's about generating light, controlling it, detecting it, looking at photons, looking at those kind of things. And I feel that it underpins pretty much all of our modern technology and how much more we've maybe developed dependent on photonics than we were 5 years ago when it was the International Year of Light, and that these photonics are everywhere. So I'd kind of like to pose the question out to our industrialists first, kind of like, maybe what do you think photonics is to you and to your industry and to your business in particular? So please feel free to unmute and jump right in. So what do you think photonics is to your industry? Anyone would like to jump in?
I can start then. Sort of, I guess, for our technology, we're involved in parasite diagnostics and management, and we're looking at solutions that can be used remotely in penside, on farms, and vet practice, etc. We used to be microscope based, so it all microscope based. We changed to this digital imaging kind of solution. So this device you can see over my shoulder there, kind of as an outline, is kind of all about digital imaging. So where photonics is really important for us is, we need to capture really good, detailed, clarity images of small things in the field, basically. And where we've, where we've collaborated with the CP is the helping in, building up, and getting better images. And the photonics, the lighting, the illumination of our samples is kind of one of the key things to that, as well as helping lensing and sensors to be able to kind of capture those images, using the light sensors and so on. So for us, that's where it's a critical way for us, and our expertise, if you would, is very much at the other end, is actually using the information and the data that comes out, the results, helping farmers, horse owners, and so on understand the parasite management and so on. But for that, we need to, have the knowledge from the field and the results, if you went, on the data, if you went from the field, and that's generated, by these digital images. So we've had to learn a lot about that side of things, and that's where the link with CP and Aberystwyth University has been really vital for us. Yeah.
Oh no, thanks. That's really great. It is interesting when people say photonics, they think it's going to be some kind of small high-tech components, and I can't possibly need that in my business. But actually, it's sometimes just understanding how to manipulate that lighting and the settings. That's a really good point. Kelvin, you were going to speak as well.
Yeah, I mean, without light, we wouldn't have a sparkle in our diamond. So. No. Light for our industry obviously is extremely important. So with the help of you guys, particularly Vanguard at the moment, and Aber, you're both doing some really good projects for us, really good, totally innovative. And it's going to, what we're trying to do, particularly Vanguard now, they're trying to put nano engraving on a QR code on the inside of a diamond for us. So it's going to be nano size, and at the moment they've achieved something like 0.7 of a millimeter into the diamond, but using about a micron size. But we're going to get down to nano size very shortly. We're using that so that we can use it for, in our industry, twofold. One, for the traceability, where it can come from the mine. So every mine that's mining the diamond now can now QR code it, and then put it onto the blockchain. So we'll have blockchain technology then to form a traceability on the stone. The other side then can be for identification later on, for valuation, for traceability, for ownerability, put it that way, for one of the better words. So if you've got a diamond ring and it got lost or stolen, then it can end up whenever, somewhere in the world. We're developing an international database and an ID system, whereas you can then identify the piece by using the QR code onto the blockchain, and the ownership can come back to you or your insurance company. So all this is connected, will be connected worldwide. So it's, I mean, can't do without it. We've got two main projects. There's another project we do with as well that started up in Sheffield University, and that's just finished. So it's all, all to do with photonics. Amazing thing, amazing. Can't wait for the next project.
You're using lasers in a very unconventional way. Someone might say from maybe another industry, the diamonds, that's quite an unusual application for photonics. But from your point of view, you're using it from the jewelry side, and I use diamonds in my research from the photonic side as nitrogen vacancies in diamonds for quantum computing. So it's quite nice to have a diverse range of one material can be used for so many things. So you're preaching to the converted with diamond on my front. But like that thing, the project that you've got, the collaboration with Bangor there, with using the laser marking, that might be also something people don't think about photonics. And can you imagine that maybe 10 years ago, where did we see lasers in our work every day? Whereas now we're seeing the use of laser marking and laser milling and everything like that. And that's all photonics. That's all being driven by the photonics revolution, kind of like in developing these new lasers like what Bangor have got. So yeah, it's a brilliant application as well. Thank you for that. Nigel, is there anything you'd like to add as well for photonics in your industry?
Yes, I think so. Up until 18 months ago, photonics was new to me as well, and I've really had my eyes open, and it's really taken me on an amazing journey. When I started with this business, it was heavily mechanically positioned. The whole benefit globally from the guys in Singapore was all positioned towards mechanical benefits. And when I took over the operation for Europe, and I realized what we could do using different technologies, and what you're saying about photonics, 100% right still. I engage with people all across the world now. But the majority of people, when I say photonics, most people haven't got a clue what I'm talking about. And what really inspired a huge leap forward for us when we spoke to Aberystwyth and all the photonics team, because it really has made a substantial difference to our strategic vision now where we're going. We've gone from a mechanical system to a smart system. But I don't know if everyone can remember the Blue Planet sort of program about plastics and the fishes and everything else. And we got into a heavy conversation with some guys in America, and we started talking about photonics, and it was no idea. It must be spaceships and things that go to Mars. And obviously, as we explained what we potentially could do, we would change what we were going to do going forward. And with the help of Aberystwyth, what we ended up doing was really changing our technology. We changed the cartridge from being something that was just going to really measure flow and probably the turbidity of what was going through the pipeline. But it started to evolve now, where it seems to be growing and growing and growing, where people are now saying, well, if we can do this with photonics, can we do this? Can we do that? And what I think we're very fortunate about in Wales, and you know, I'm a very passionate Welshman. I like the fact we've got the business here and we've got all this technology here, is the fact we can now come back to you and say, and I'm quite happy to do that because I'm a novice, I'm the new person in it. So to come back and speak to Caroline's team and say, can it do this? Can it do this? Can it do that? And there's nothing wrong with that, because those are the questions on the heavy engineering side that I'm getting asked all the time. Well, you know, can we measure the volumes of gas compared to oil going through a pipeline? I don't know, but there'd be nice questions to ask people and do some projects together. But I think we're only scratching the surface, and with our business at the moment, this is what we're saying to the industry. You need to digitize. You need to be able to take the technology in and out the pipeline as it evolves. And as I say to people, think of the iPhone. The iPhone 1, it was completely different to iPhone 12. So when you start digitization, it's a journey. It's the beginning. It's not the end. So it's going to evolve. And I think this is where, and I've always believed this when I used to work for a German company, academia and what we're doing here in Wales now in industry is absolutely fundamental in giving smaller SMEs and big organizations the edge in the marketplace to be different to the competition. And that's what everyone's looking for. How can we offer the end user, the client, something different to our competitor? And if we can, we're going to get some additional revenue. The profit margins will be better. So yeah, it's been a great journey for ourselves. Simon and John have been wonderful, taking us through the processes. We've fallen over a few times and come back to the beginning, but I think we're coming to the right solution now. So, and we've got a major sensor manufacturer based in the Far East who are looking to manufacture it with us now. So that'll be, as I see, iPhone 2. We've already got the cartridge in. It's already working around the world, but this is stage 2 using photonic technology. So we're really pleased. We're really proud to be part of what we're doing.
I expect to see a Steve Jobs turtleneck and presentation against the screen then shortly.
No, that's not that's Simon's job, my colleague. He's the one that does that. I'm trying to get everything, all the operational and the supply chain, and it seems to be working really well. So, like I said, we're really pleased. We're pleased to be here.
Brilliant. I mean, and that's a really nice application as well. Kind of what you said is like something, we've got with the three of you here, we've got quite a wide range there of applications in industry of how you use it. That are completely different spectrum as probably what a layperson maybe coming into it would think they've got there. So I don't know, Caroline, if you've got any kind of insights as well, because you've worked in so many different optics businesses and consultations and things like that, so you've seen optics develop as well from a different perspective probably.
Yeah, I have indeed. And when first sort of came up with the thought train for the Centre for Photonics Expertise and that partnership and bringing together that, what I see in front of me now is exactly what we set out to do, is to bring photonics to all the sectors and all the businesses and such diverse range of applications, just with our three panelists today. And to date, we've done 45 projects, so that's 45 new applications using photonics. And the idea was that this isn't new research, this is applications of research that's been undertaken by Welsh universities over the years. So you're getting years of experience and background of skill, and it is very accessible. And that was the key difference, I think, between the CPE program and others, is that to take that technology and make it accessible with a simple format to access, to have that capability and that capacity ready and waiting for people, and not to have a long access chain with breaks and making it difficult. It's it's a cash-free transaction. It's a collaborative program. So in many ways, your time, our time will make the product stronger. So that's exactly what we set out to do. I'd like to take you back to the diamond application though, because my background technically is in a process called single point diamond turning. So I too have a diamond application background for photonics, and that is using diamond to directly machine the optics that steer the light in optical systems, making complex optics. So I too am a diamond lover as well. So that's where my technical background is. So it's got a lot to answer for, that stone.
It has. I know. You think that's why it's been so heavily studied for all this time as well, and so popular still in the studies of it. And it's great to be able to get as well. Like the part of, like you said, really is a collaboration. Is how we're working. In that we get these excellent quality samples from Kelvin to look at these techniques with as well. So we are getting something out of it as academia as well as academics. It's always exciting as an academic, where instead of getting a trade catalogue, you get a diamond arrives in the post.
Diamond in the post. And they're much more sparkly than the diamonds I used to use.
Run after the courier that day. But yeah, it's been a really great collaborative project. It's certainly the one that I would say that I've got the closest to businesses in this kind of project, because like you say, Caroline, it's not taking that frontier of physics, of technology, frontier of photonics, of what this new obscure field is. It's taking it back to something that's actually useful to people on there and then. So it's bringing things up from that abstract concept down to a high technology readiness level, where we can go, yeah, we know a camera that you can put on your production line that would massively improve it, or we know a lens that you can use. So I think it's nice to hear that people don't think academics now are as much ivory towers postulating things as we are actually wanting to help as well.
I like to think that CPE is the academic equivalent of sweating the assets in industry and manufacturing sense, where you get the most out of the assets you've created and invested in. Universities have invested in research, and now CPE is sweating that asset to bring it to industry and make it good and help it grow the economy. And that's the link between what we do in universities and what businesses need. And like Kelvin and Eurion said, and Nigel, obviously, who I know well, and they've all taken different aspects of the expertise and used it to their own advantage. And that's what we want to continue. So anybody who is listening in who thinks they might have an idea or something, get in touch. It's a conversation and a simple form, and we can get started.
Yeah, exactly. That's a really great
Can
point.
I jump in on that, Rachel, if I may?
Yeah, please do.
Because having sort of seen that as well, it is very difficult, because I think that the perceptions have changed from the university towards industry. I think industry needs to sort of embrace academia more. I think that's where it needs to change. And I do agree with what Caroline said. I think that CPE sort of form and how it's broken those barriers has been very, very good. But it's the conversations I've had with people outside the country when I talk about photonics, and you can just see them just glaze over immediately. And you think, they're not going to want to talk about this. And the conversation I've had with our senior engineer, I said, well, the best thing to do with it is say, here's our problem. Have you got a photonic or another solution that can help me solve this and improve what I'm looking to do? So I was pretty fortunate because I'd seen that before, and I brought that into the business as soon as I recognized it. But the amount of people who I had to try and convince was quite difficult when I had to go back to the market. And I'm sure we can do this doing this sort of technology is really difficult. But yeah, I think academia's come a long way to embrace industry. I think industry needs to sort of come to the middle ground and embrace it a bit more personally.
Yeah.
I just add to that. I'll just add to that, Nigel, as well. I mean, just we found it. I mean, we've been down this process before, and we've collaborated with academia, over the years of developing what we do. But we've been in the biology and the environmental side, and actually it was working with the IBERS department in Aberystwyth University. We were dealing with samples there from various animals and so on, and I know now why you're probably less excited when you get a sample for the post from us, because it's fecal material or a stool sample from a sheep or a cow, so a bit less exciting than diamonds, yeah. But we are, we've done a lot of that work before, and we had a link through to here because we were having difficulty with illumination and dark field illumination and all this kind of thing. And unbeknown to us, as somebody in the next building, who had all this expertise, sort of, and I would say that the structure of CPE and stuff has made it very easy to kind of access that as well. Probably easier than we've had in the past, with the biological side. It means probably more difficult kind of to get through, and applications and so on. So actually, it is something that's very accessible, for companies, sort of that do need it, sort of, and going back as well to the link between research, academia, and industry. What's great for us, we do have a team there who, they're in academia, but they understand kind of what industry needs as well. It's that commercial kind of, common sense, if you want, which I think in the past academia, probably didn't have maybe sort of, but it's actually linking that to what's going to be applicable on the ground and what's useful, sort of, rather than pie in the sky science.
Yeah, I agree with that, and we've embraced the photonics side, and we've embraced the MADE program at Swansea University, and I can't say anything high enough about both of those collaborations. Have been exceptional, because I can only see it commercially, because it is commercial for us as a business, and is it going to give us a stronger footprint, a stronger USP into the market? But the great thing about it is and it's been seen as a failing when I first sort of dealt with it, is timescales. Academia tends to look at timescales differently than industry does. But what I've found quite amazing now is that it's changed, because by engaging stronger with them, I've said, look, we need to finish this by these certain dates, and this is where we need to be and the reasons why. And they've just bent over backwards to do what we need to do, because they see their success as us being more commercially viable and more profitable. And then they see that as being a success. So I think it's been a real positive swing in the right direction over the last couple of years. And I think COVID will enhance that personally. I think we're all going to be a little bit more dynamic, with innovation, and try and find that, that extra.
I think that's right, Nigel. I think like with the dynamic kind of thing is we're a lot more interactive now, maybe because we don't actually have that transport barrier where we can all get together now and just have these chats. So and it's nice. It's really nice to hear that as well from like a CPE point of view, from a project point of view. We're very lucky that this project maybe is a little bit different than normal interactions with academia, in that we have funded on this project dedicated people to do this work with you guys. So it's not a case of having to fit it as much around teaching and other commitments and things like that. We've got our people kind of in each university kind of ready to go, and I think that's what makes it a really successful project. Just kind of thinking about where we're going now next in the future as well. I just kind of like to bring Matt in on your kind of views from a KTN point of view, of where you kind of see the growth areas in photonics and business, and how these kind of areas bring in and other sectors, and how do you think maybe we can build on those things?
Yeah, sure. I'm struck actually by the iPhone analogy that we had earlier on. So here's what we got. So here's one. And there are something like, I don't know what the latest is, like 30 photonic processors involved in making one of these at least. So if you think about this, there's the lasers are doing things with the glass that's impossible to do in any other way, embedding sort of things in it. Inside it, the electronics that make it work, the lasers are involved. This particular new one is a sort of fancy one, so it's projecting an image onto my face so it can recognize me when I unlock it, using the kind of things that are actually being manufactured in South Wales and photonics side at the moment. So, and that actually moves into one of the huge growth areas for photonics. And there are many, but one of the massive ones has to be communications in general. The growth of it and the data needed to handle that, and in the data centers. So if you look at any kind of graph, you see these like huge growth areas that are coming from this, and it goes all the way from sort of transmitting signals and fiber optics. So people say, well, I don't know what fiber. I always say to people, so I do photonics, lasers, and fibers and stuff is what I generally start off with. But the fibers, lasers, and things like that are driving this growth. So that's a massive area. You could actually name loads of different ones. So agriculture, and that's our agri-food going into a big societal challenge. Feeding the population of the earth. And with climate, and we're starting to see things like indoor farming, where control of light at specific wavelengths for specific periods of time to actually feed the growing population, and then even outside, with sort of sensors to look at crops and their properties and measure sort of diseases. More wider manufacturers. I talked about the iPhone. Huge growth in that. Lasers can do things that you can't do elsewhere, or go places that you can't do, and achieve these products. The UK is still lagging behind Germany, for example, in the use of lasers in industry. So that's a real sort of interesting one of doing the missionary work of getting into manufacturing and saying, you can make a more efficient process, you can do something that you couldn't do before from it. And if you want the real kind of Star Trek-y one, if you like, then the sort of rise of quantum technology is one. So we say not all photonics is quantum, and not all quantum is photonics, but photonics and quantum are pretty well linked, and we're already seeing a lot of quantum, well, a lot of laser companies and photonics companies are sort of seeing that they've got an angle in quantum technology, and we may see a quantum industry, or forecast to see a quantum industry emerging in the coming years, and photonics will absolutely be a part of that. So you could pick almost any area of societal need or economic growth, and photonics will be under it somewhere.
Yeah, I totally agree. It's quite funny to think that all the areas that you've mentioned in, I think I've either worked or know someone who works on a project that's similar like that. So, and with the iPhone as well, thinking about using LiDAR, we use, for doing range finding, you can measure a room now with it. That's all photonics. How many applications can you use that to? We use that out in the field for precision agriculture, saying where we want to do things, and CP has done projects on looking at the illumination for indoor grown crops. So yeah, it's really nice to see those resonating with things that you've seen across the sector as well as what we're seeing. Caroline.
Yeah, one of the growth areas is obviously very topical, is the use of UV light and sterilization for in a post-COVID world, applying UV technologies for virus killing and cleansing of areas on a wide scale. People are looking at safe UV applications for hands, as you would do when you clean your hands, looking at doorways, looking at all sorts of applications for UV light in the post-COVID world to try and prevent such a rapid spreading of such a virus in the future. And going back to the communications that Matt said, LiDAR, you touched on Rachel, without photonics, things like the aerial platforms, the unmanned aerial platforms that are being developed by the large aerospace companies now, they're using photonics to get the information that's being seen, crop rotations, persistent surveillance of cattle migration, and going into areas of the world that are hostile, using not using people anymore but using automation. All of the information coming back from them applications is a photonics application using LiDAR. LiDAR is like radar, but it's light. For simplistic terms, and all of these applications are the next generation of photonic applications, certainly.
We can definitely say, I think quite confidently, that we're definitely going to see a growth in photonics, which is good for me with a good few years of my career in front of me. Sorry, go on, Kelvin.
Yeah, there was, I don't know if you know, but a huge laser company in Germany called Coherent, and another large company, Lumentum. Lumentum have just bought out Coherent, and it's such a two big companies, but obviously Lumentum are even bigger than Coherent, and you can see how photonics is important. That these two companies, both not just heavily involved, they are photonic companies involved in lasers, purely lasers. What they're doing to the industry. I mean, they're helping us as well. We've collaborated with Coherent now. We just found out Lumentum, but you can see where the future's going with it. To get two massive industrial bodies being involved together and talking billions, hundreds of billions of dollars involved just in the company. So that's obviously not going to do that much money without knowing of the future.
Yeah, knowing there's an impact.
I just sort of build on what Kelvin said there. So Coherent have, in fact, they've just expanded their factory in Glasgow. Yeah. So Coherent have a big UK presence, and one of the reasons that they are remained and grown in the UK as well is the actual sort of the research base and the photonics industry that's in the UK, and the collaborations that go across the UK. So and it's testament that rather than moving that factory, just to have one of their operations in the US, they actually grew that factory. So it shows that the UK has got great strengths in this as well.
We had a chat with Coherent not so long ago, and trying to get them into Wales. They're thinking about it.
I'll buy some lasers. I've got loads of lasers. I always need a good laser. Sure, I'll find a grant to buy one. Tell them I'll buy one. Yeah. That's it's really great to hear about all like kind of like these different perspectives, and kind of like the emerging thing of where we're going to innovate and where we're going to push photonics through. So kind of thinking with your companies, everyone's touched a bit about on we're innovating with these projects with CPE. I was just wondering if maybe anyone wanted to comment on, we've said like people have enjoyed their experience, but maybe how easy it was to kind of like interact with academia to try and tap into that kind of like blue sky thinking that we do in our coffee rooms, down to being an actual useful thing down on the plant floor to you guys. So how have you found that kind of like tapping in kind of process?
It was easy, very easy. Once you got the academics to come down, not a peg or two, but a peg or 10, then on the same level as any industrialist would be, then the conversation just flew. And once you showed them a bit of excitement of what a project that you were going to be involved with, or what you wanted to be involved with, then immediately you got the excitement from them. So once you got excitement, together with two. That fuses a good partnership immediately. And all I can say is, between the two sections we've had so far, what a wonderful relationship. We don't have a relationship, we have partners now involved, and these partners we don't want to lose ever. We want them for life. I want to buy them.
You can't have my postdocs. You can't buy them.
Can I borrow them now and again?
You can borrow them now and again, of course.
This is what I want.
I just, I'd agree with Kelvin there as well. In our experience, it's been great. It's about, as in all aspects of life and the work in industry, it is about people in the end. We're talking about technology, but the people are important. And experience we've had, is the people are enthusiastic about the science, but also enthusiastic about applying it. We found our experience with the team, in Aberystwyth University with Rachel, is they spend a bit of time to understand what we're trying to achieve, where we apply it. So for us and stuff, because we're going to apply it as a pen site on farm, we're not talking about machines that costs tens of thousands of pounds in a lab somewhere. We're talking about bringing the lab out to a pen site, to a farm. So the cost of what we're doing is quite important and stuff, So it's having that commercial nous to be able to, and even that practical hands-on, John and the team, they've dismantled our device there and stuff and started rebuilding it and stuff. It's having that enthusiasm. Sorry?
We did ask first.
We did ask first. Not the one we gave you when we told you go away and break it. Absolutely, yeah. But that's what, it is. It's about the team that's there and that enthusiasm for what you're doing and commercially applying. So I think it's been very easy. It has been so far a very easy process and one that's growing and evolving for us as well. We're putting the second now. We're fairly new into this, but we just putting together the second CP kind of application at the moment. So it's kind of it's been great.
And would you say that it's an easy process to kind of like work with us to as like the whole project, not just obviously Aberystwyth, but the whole CP project, the paperwork and things like that, and it's quite we've tried to make it as simple and elegant as possible. Obviously there's always contractual things and making sure everyone's
I would say I'm going to jump in and say I think that's one of the great pluses that and the MADE program. There's a couple of programs now when people get a little bit frightened of doing something with academia or anything to do with government sort of grants or loans or any sort of collaboration, is the reams of paperwork that you have to go through. That seems to have really disappeared. I think it's really engaging with the right academic as well, Rachel. If you find the right person who really fits that model, which is great about the CP, because I know Caroline's pretty keen on that, is identifying the right person to slot this with the right company, then it works really well. As long as you've got a vision. I know I had great fun with both John and Simon because I've made a complete hash of the first one, totally all my fault, went in the wrong direction, and yet when we went back to revisit, because Thames were driving this with us, and I spoke to the CTO, the chief technical officer at Thames, and once we got them all talking to each other, we really understood what we were trying to achieve and why. Then it was really, really quick. It was very, 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 very sort of seamless process from start to finish. It took 4 weeks. And the other thing that I found, which we probably don't talk about as much in industry, and we don't share it as much, but because we're sharing information with academics and on a different sort of field, because academia looks at technology different than industry does, and we have to bring that together, is we can share information with people like academics and we can really drill it down to the nth degree and share everything, because we're not really sharing it with our competitor, if you know what I mean. If we went out and I had to share all this information with a sensor developer that was going to go inside our smart cartridge, then at the back of our mind at a board level, you'd be thinking, we're giving all our information away here. We can sign an NDA, but this information somewhere down the line is going to pop up on somebody else's technology. But when you're doing it with academia, it's sort of locked in, if that makes any sense. You feel comfortable, you can share everything because it's all going to come back to you. And unless there's any major, huge IP benefits that you have to discuss together, then it's straightforward. Then there's nothing to worry about. So I found that quite a benefit.
That's really nice to hear. I mean, is there any kind of advice that between the panelists that you could maybe give businesses in looking to maybe invest or embark on some new R&D and how maybe they might approach it? Is there anything that you could maybe give some advice to the people listening and joining us virtually for this discussion?
Well, I think that's a terrible question for the simple reason, all the guys in industry here that are using you guys in the photonics, why would we want to promote it to lots of other people when it's going to get so damn busy that we can't get in anymore?
Because we just get bigger grants and get more people.
This is one complaint I've got about the CPE. There's not enough of you. Need more.
Right to your local AM.
Yeah, that's really good to hear, Kelvin, and you're right. You know, why would you want to eat into your own capacity? But you know, it's great hearing what you know, that we've achieved what we set out to achieve. Just looking in the chat here, there's a couple of questions around who can do what. So let me address that. That basically CPE is open to any company that has a base in the West Wales and Valleys region of Wales. It's unfortunate our funding is restricted in that way, but that's the nature of the funding. It's ERDF funding, European funding. Yes, we are at the bottom of the barrel, but it's still there. So so it is European funded. We are hoping to extend the projects, and it's testimonies like these that we're hearing today that will help us get onward funding for the team and for the initiative to grow throughout Wales. Getting involved, if you're in the West Wales and Valleys region, it is literally an email or a phone call, and let us do the rest. Carol and Hazel, our business development managers, they are fantastic. They will just be all over it and get you sorted and get you with the right academic team and get your project off the ground. A little bit of background as to why CPE and how CPE came about is I have an industrial background, and I've shaped CPE around some of the frustrations I had during my industrial career about trying to access academic expertise and some of the fundamental issues I had. So my background has helped me maybe underpin some of the previous models, and it's the model of CPE that is now taking shape and allowing companies to access it. So, you know, just to recap, it's very simple, it's very quick. It doesn't cost you any cash. You invest your time and your resource to match that of the academic, and we will discuss your challenge and make sure that the right academic team and the strongest academic team to provide you with the best solution is appointed, and you leave, yeah, and you take it from there. It is straightforward and accessible, and you know, there's no limit really. It doesn't matter what sector you're in, you know, whether you're, you know, making diamonds or looking at you know, parasites. You've seen the diversity here of application just on this panel, and we've got others as well. We've got sort of satellite, you know, initiatives. We've got all sorts of things. So get in touch. We like variety, so see if you can spread our diversity even further.
I'd add to that, you know, I think the team are very helpful in the application process as well. So, you know, if you're thinking about it, just have a chat, you know, to somebody and stuff, you know what I mean, because they'll help you through the process. You know, that was a really good guidance. So it is very easy. Yeah.
That's great. I can see now, looking at the clock, that we've got like 10-15 minutes left, and we said we'd open it up to any questions from any of our attendees as well, just to see what we can do. So I'm just going to invite Mike, who's one of our CPE team as well, to maybe read out a couple of the questions from attendees to pose to us. He can be our virtual attendee and read them out. So come over with a mic.
Thank you very much, Rachel, and big thanks to all the panel members for their input today. We've had a wide array of interesting questions, which I think we may have touched upon a lot of those during the presentation today, but we'll try and answer as many of the more direct ones as much as we can with the time that we've got left. So one particular question we've had now, they mentioned electrons were discovered and then electronics as a new science or industry came along. Would the panel like to comment on photons and photonics and their joint venture with electrons known as photoelectric?
I think Matthew's got his hand.
What's in a name? So it's interesting actually. So photoelectronics. So we had the photoelectric effect, is what Einstein, I think, got a Nobel Prize for quite some time ago. So photonics has been around for a long time. We're probably not talking about the sort of control of photonics. Not a few years ago, we had optoelectronics, which is pretty much photoelectronics. And in fact, you know, you still see a lot of optoelectronics used as a name. And there's a question about whether we should shy away from using photonics. And one suggestion, as a name, that is, not as a technology, one suggestion has been just to replace it with optics, because it's something that politicians might understand more readily. So I'd be inclined, if we go in, I'd be inclined to be brave and stick with photonics. We nearly got Barack Obama to say it. There's a great video actually that they ran a project in the States to sort of to get decision makers saying it, and he got as far as photonics, so he got close. So I've been kind of persevere with photonics, maybe use optics as a sort of proxy, but probably trying to make it sort of shorter rather than larger when trying to use a word like that. But essentially, as we've heard today, I mean, the thing is, you just come up and say, you engage with CPE and partners and whatever, and just say, this is my problem, and not worry so much about what it's called. That's where I'd go.
That's great. Yeah, thank you. Yeah, that's really great. Yeah, definitely. I think we can see that there's always an old equivalent to anything, and we do like a sexy name in physics to put on a nice paper as well. So the longer and sexier name goes with the paper, and then something a bit more appropriate for everybody else. So Mike, what's the next question?
Thanks, Rachel. Another question that's come through, with the many challenges that are happening both environmentally and economically, namely COVID-19, Brexit, climate change, etc. What are the panel's thoughts for the future of photonics and collaborations within your business sectors?
Yeah, this sort of it is interesting, sort of in terms of our technology and where we see it and stuff. You know, I mean, sort of the data capturing and monitoring of things like disease, and we do it in animals. And I think Matt touched on the monitoring disease in crops and so on, etc. These things are going to sort of become far more important. The environmental impact of growing food, etc. Can we make that more sustainable? The need for more foods to be able to kind of to sustain the growing population, etc., and doing that without damaging the environment. So trying to kind of grow crops, and food, and we're involved, more in the kind of animal kind of livestock side of things. Doing that in a sustainable way is going to need a lot of technology, data, and information to actually help drive that forward. Because I think, there's a lot of things like diseases, and we're involved in disease control and so on. Diseases will actually drag down. So, we are seeing these continued pressures. So the role of technology in that, in answering some of those pressures is going to be, an increasing thing. And I think photonics has, got a large place to play. And for us, we're looking at other applications. We're looking at other parasite diseases. We're also, even talking at the moment, about going into the kind of, we've got people in the medical field who are interested in what we're using in the veterinary science. And so that's the kind of new application for us as well. So yeah, from my industry.
So for the kind of projects that you've all been doing so far, I was just wondering how the panel have been funding their kind of like interactions with different with the academics and with other maybe areas that you've been kind of getting R&D development on. So what we've touched upon, mentioned a few things as we've gone along, but I don't know if maybe Matt would like to touch on some kind of methods of grant funding and investors, and if any of the other industrialists or Caroline would like to chip in as well on that question.
Yeah, I'll start and people can go in. So really, in general terms, you want to be looking at a basket of funding. So there's not one solution is gonna fit everything. So what and I'm sure the panelists would agree that sustaining a business solely on grant funding is no way to develop a growing sustainable business. So Grants are part of it. Obviously, sort of in investment. You know, if you're in an early business, you'll start with your kind of bootstrapping cash and your sort of early sort of angel rounds and things like that. But it's about building the right team of people and having the funding. So you want to be looking at grants, investment, debt finance. You know, for some things, you know, loans are you know, something that you should use as another financial instruments like that. The innovation loans, really successful pilot. I don't think we've seen the end of innovation loans as well. And if you go and look at some of the case studies on the innovation loans, there were some spectacular sort of projects and stuff that got delivered through those. And I mean, CP being a great example, and the funding that's specific perhaps to a specific sort of location. So there will be funding in your area, your country, your region, likely that you can use for that. And actually, don't forget, we are still able to access Horizon 2020 and Horizon Europe funding. So there's a little sort of celebration as the UK finally managed to associate with the EU. So we can still take part in existing Horizon 2020 funding, and European projects are still available to us for those bigger ones, and for people new in those, get involved in a consortium with people that know to do it. But basket of funding, that's my takeaway from that.
Thank you. I think there's just been another question pop through, Mike, if you want to pose
yeah,
that.
Sure. It's just come through now. It asks the panel, do you also do any work with Li-Fi? And if so, do you see it becoming popular in the future?
Okay. So for people that need that explaining, so Li-Fi is Wi-Fi with light. So you know, it's all photons. So there are some really good use cases for Li-Fi. The data rates are spectacular. It's an interesting problem and benefit of the technology that you need line of sight. So in my house that I'm in here, I've got a Wi-Fi box that's sort of back there somewhere, and it's transmitting through a few walls, and you couldn't do that with Li-Fi. However, if I've got Li-Fi, that if the counter of that, it means people can snoop in on me. So Li-Fi has got some really good use cases for privacy and security. It's got some kind of interesting use cases within sort of buildings and in environments perhaps where, you know, you can't afford to have anything leaking out, or you don't want to be transmitting anything with radio waves. So it's, you know, the growth of it has been slow, but still sort of progressing. So it might be one to watch. I don't think it, and then the people that supply it never claim it's going to, I think, take over all of our communication. But Li-Fi might take a sort of an increasing part of the load in communications in some specific cases, I think.
Well, that's great. Thank you very much for chipping in on that. I was just going to chip in and say that we have like the Radio Spectrum Centre that we're setting up in Aberystwyth, that we're going to be dealing with lots of different communication aspects, looking at, you know, 5G and the future things, and photonics is obviously part of the electromagnetic spectrum when we can think across it. So thinking about the Li-Fi as part of that is kind of part of the bigger picture, where we're hoping to drive a bit more innovation into improving those kind of communications, especially for areas where we can't get things out to people normally, to enhance coverage for people, because it makes everyone's life a little bit better. I don't know if there's any other questions, Mike, that are...
Yes, I think we've got time for, looking at the clock now, we've got time for just one more, and then this is mainly to the industrial partners on the panel. What do you think have been the main impacts of your CPE projects in terms of outcomes?
Well, shall we take that one? It's, well, one of the projects that we're working on now is with the marking of diamonds, can also be marked on the inside of a hallmark of a piece of jewelry. Well, what we're looking at now is we're looking at a national marking centre that can involve that. Like you've got a hallmarking area where you've got a hallmark, you've got 4 hallmarking areas in the UK. Well, if we can develop then, along with the government, a national marking centre, what that's going to do is going to encourage jobs. So we estimate within 5 years, there should be at least another 1,200 to 1,300 jobs available for that enterprise. Not we take it on, but the government would take it on, and along with other companies. So this is what it's doing. Photonics are doing. They're encouraging, not encouraging growth within companies, but encouraging growth within the employment sector. So that's kind of vital.
That's brilliant. I think we're coming to the end of our allotted time on our session. And if we were at an in-person conference, I'd say let's all gather around the coffee and biscuits, as that is a very important part of conferences for me. Or drinks, a bit early though, isn't it? Really.
Lockdown.
But, yeah, lockdown drinking. Yeah.
Cocktail time somewhere.
Yeah, exactly. But I would like to just draw this session kind of to a close and thank everybody so much for your time today, for joining on this. It's been really lovely to hear such positive comments about the projects, about photonics as a physicist working in photonics as well, to know that there's a want for industry, a want from funding and things like that, and to push it forward. And I really hope that some of the people that have joined us on the chat and things like that, and that we've answered their questions. If there are any other questions that we didn't have time to cover, or that you think of after, or you're interested, some of them about actually interacting with the projects, or just some advice, please do pop over to chat to Carol and Hazel over in the CPE booth, and they'll be able to answer any questions. But other than that, I'd just like to thank again all our speakers. Thank you very much.
Thank you.
It's been great seeing you all together on the screen, and have a lovely afternoon and enjoy the rest of the conference.
I'd like to thank you, Rachel, as well, for excellent chairing and everything else. So thank you very much.
Thank you.
Thank you.
Take care, everyone.
Thank you, everybody.
Bye-bye.
Take care. Bye-bye.
Thank you for joining the Emerging Tech Fest. Join us again on our virtual live sessions, or watch us on playback anytime, anywhere.